All right, we're on air. Hello and welcome to the, what is this, March 2018 edition of Community for F#. We are pleased today to have Mr. Eric Potter joining us for a live coding session. And I'm going to hand it over to Eric to let him introduce himself and also what we're going to be looking at today.
Yeah, like Ryan said, I'm Eric Potter. I'm a software developer for Aptera in Fort Wayne, Indiana. I have been an F# dabbler for a long time and thoroughly enjoy it. I've recently been playing around with the Azure Cognitive Services and wanted to get some better documentation around how to call those services with F#. And it was recommended to me that rather than just documenting the current API, that we actually create a wrapper that makes the API available in a more idiomatic way. So that was kind of the idea behind the library we're going to look at today. It is called FognitiveServices because I couldn't think of a better name. So that's the project.
Awesome. And maybe Fog is looking forward to the idea of multi-cloud, as I've heard, heard the term used before.
Maybe.
Cool. All right, so whenever you're ready, go ahead and share your screen and we'll start taking a look. And if anybody else who's viewing has any suggestions or anything, we'll be watching Twitter. You can tweet at C4F#. And if you have any hints or top tips or whatnot, we'll be glad to share those and incorporate those things as well.
All right, so there are two APIs that we have right now. One is a wrapper around the Vision API. So this is the API that will take an image and return a caption and some details about it. And the other API that we have a simple wrapper around is the text API. So what it does is it will take some text and either return the key phrases, the language, or the sentiment about the text that was uploaded. So right now we have a test client for both of these. You can see in this case, it's uploading a test image called dog.jpg. And if we run this, it will call out to the cognitive services and try and pull back the information. Let's see what we get back. Yeah, so it's the cognitive services is returning a description of a dog looking at the camera. The tags are dog, animal, and mammal. These numbers are the confidence levels. And then it's saying the primary color of the image is white.
Yeah, it's interesting. Well, a couple things. So one, I noticed that command window said it was running .NET X. So this must be a .NET Core or Net Standard app?
Yeah, the libraries are both .NET Standard apps.
Okay.
And then the test clients I have are .NET Core.
Cool. And then the next thing was the confidence level, as you mentioned. It looked like it actually got less confident as it went up the hierarchy. It's like dog it was most confident on, then like mammal and animal got less confident. That seemed kind of interesting. Is that the way that this typically works?
I guess I don't have a ton of experience. I have found that it does bring the tags back sorted by confidence.
Okay.
So it looks like it's 99% sure it's a dog, but only 95% sure it's an animal. But you're right, that does seem a little strange. You'd think it would be more convinced that it was an animal.
Yeah. And which picture is this? Can you show us the image so we can see?
Yeah, let me
verify not just that it's dog.jpg, but also it is, not a cat dressed as a dog or something. This has nothing to do with the code. Oh,
No,
awesome.
that's the image that it's testing against right now.
Cool.
But just for the sake of argument, let me run a different one. And this would be an image that has both a dog and a cat in it. Yeah, so this one I guess is a little different. It's 94% convinced it's an animal, and then 93% convinced that it's a dog and a cat, which there is actually both in that image.
Yeah, and mammal is still less certain than dog and cat. That's interesting. Cool. Okay, sorry for derailing on the.
No, I think this is the image that we were testing against, by the way. No, I think it's valuable because I think that the cognitive services are really interesting and really powerful. And that was kind of the driver behind this little effort, was I just wanted them to be more approachable to F# programmers.
Okay.
Because as you can see, like the client call itself is really not that much more than just a REST call that we have to pass in a couple different feature types that we want to look for, but yeah, it's a very small amount of code to actually get to actually get that information back.
Yeah.
We're having access to this giant machine learning algorithm in Azure.
Yeah. Cool. Okay. Well, one of the things I know you mentioned to me was, how can you make this more idiomatic? Like the first thing that stands out here is just like a quick thing you might want to consider changing would be, you have a client here, client.create looks good, but then client.analyze image async takes the client first and then the test file name. And that's not necessarily a bad thing, but and this one is async. So there's not really an easy way to chain this with the async computation expression. But if you had some synchronous methods, you can't really pipe these functions because the client would have to be one of the things that gets piped out, like probably at the end, or piped out at the end of the argument list. So if you switched client and test file name here, you might make it something where you could actually pipe client to client.analyze image async test file name. Now that sort of depends on how you actually want to use this. So if the goal would be you want to probably partially apply a bunch of these functions at some point, like you want to partially apply analyze image async with the client, and then you just have a function you call with test file name or whatever other sequence of functions you have, then this would be a good approach. But if you wanted to be able to like pipeline some of these things, then you might want to put client at the end, or typically you put like the thing you want to pass multiple times along at the end so that you can pipe it into the function call.
Yeah, I imagine that probably what we would do is just have a single client most often and then pass it multiple files. Mm-hmm. I could see there being a scenario where maybe we had a list of files that we wanted to analyze, and then we just want to pipe that list of files into this. So
yeah. So in that case, doing it like you have it and partially applying it at some point so you could do multiple calls against it probably makes sense. So the way you have it written currently is probably the right way, if that's the way you intend this to be written or to be used.
Yeah, I think so.
And does that make sense? Like when I say partial application and all that, do you follow what I'm saying there?
Yeah, the part of it that I guess I don't have my head all the way around is how that works in an async world.
Okay.
But I imagine it's very similar where I could
yeah, we could go ahead and do it here. Let's say we want to do like a couple of test files and do them like one after the other. So underneath this, where you do use client, you could say like let analyze image equals client.analyze image async client.
Okay.
And so now if you look at the type of analyzed image, it's going to be an async function that takes a file name and returns the result. So now it's partially applied. So now if you want to do like do one after another of like several different test files, or if this was outside of an async computation and you wanted to do like an array of them and run them in parallel, you could use this one function that already has the client applied and then pass that along everywhere else.
Oops. So you're saying I should be able to do,
Yep.
I could do this.
You need to let bang because this is going to still be an async here.
Yep.
Yep. And then if you wanted to do like you have test file name listed up here on line 9.
Yeah.
If you want to like specify like another one of these, like let analysis2 equal analyze image c:\i \dog.jpg, I think is what you had before.
Nope. Let's see. Yep, like this.
You have an extra double quote there at the end too. And then copy that and then have another one that does the test file name. Oh, sorry, both .jpg is what I meant.
All right. And then do I want to print the results for both of these?
Yeah, you could even do it. Yeah, exactly. You could do that, and that would also work. Oh, that's interesting. It's letting you you don't have to rename analysis. I guess that makes sense. Those are going to be like in their own scope. So the way this is going to get compiled out is you're going to have like basically a callback with analysis as the parameter name going into print results on line 29. And then it's when you call it analyze image the second time, it's going to create another callback with the parameter name being analysis. And so they're not actually going to collide, even though it looks like they are here. It's kind of interesting. So I guess this will build and run. Usually you would have a problem reassigning with a let here, but I think just because of the way the computation expression kind of unfolds or is extended, it ends up not being an issue. Cool.
There we go.
Yeah. So I think the way that you have this now is probably pretty good. So now you can partially apply the client into the functions, and then you could chain those functions or use them however you need to use them, whether sequentially like we're doing here or in parallel, if you wanted to do it that way.
Yeah. So let's say that I had like a list of images and I wanted to get the results for all of them. How would I do that?
Okay.
I could say,
well, go ahead and define your list above op or under op, because you'll want to run this outside of the computation.
So above op, he said?
Yeah. Yeah. And I think go ahead and use a list. I think you might need to use an array, but a list should be fine. Haven't done this in a little while.
Is that the right syntax for a list?
Yep.
Oops. What? Sorry, my Vim was eating that square bracket for some reason.
No worries. And then another thing is maybe move lines 27 and 28 up as well, above op. In fact, I don't think you actually need op anymore. You do still need 27 and 28. So you get your client and you get your async function.
So just get rid of these 3 words?
Yep. And the async. The async you don't need anymore either. At least not yet. And then shift lines 27 and 28 out. There you go. Okay, so now you have an image list and you have your analyze image function. So now what you can do is say image list pipe to list.map. And then you don't actually need the parentheses and funds. So this again is relying on partial application.
Okay.
Just pass analyze image, your function name. Okay, so that will now give you a list of async functions, or actually asyncs. So now if you set this to like let something equal this thing here, you'll see the type. Let results equal. So now look at the type of results. So now you have an async image analysis list.
Okay.
Okay, so now maybe put another pipe at the end of this and pipe that to async.parallel, capital A async. The casing can get confusing sometimes. Now look at what results is. So now you have an async image analysis array. Does that make sense what we did here?
So I'm passing my image list into a function that's going to map that array onto this partial function. I guess I'm not sure what this async.parallel is doing.
So that's actually going to run them all at the same time, concurrently, or in parallel.
Okay.
So if you comment out that last pipe.
Now the result is a
so now you're getting a list of async image analysis. So when you put the parallel on there, it basically moves that list into the async, but it returns it into an array.
Okay.
So now it's one computation that will return you an array of results versus a list of asynchronous results. Does that make sense?
I think so.
Okay. So the goal of this would be that you can now run these all in parallel. And this is why so kind of looking at this is kind of a reason why you might like the design that you came up with here, where you have client.analyze image async, where you can take the client and partially apply it first. Does that make sense?
Yeah.
Okay. Part of this is me kind of thinking out in my head, like what's a good design for doing this.
All right. So then I've got this list of results, or an array. How do I then print each one of the results?
Yeah. So now you could do like this, start with continuations, but even this isn't probably necessary. Normally what people do when they do async.parallel is they'll do another pipe and do async.run synchronously. So it kind of depends on where you're running in. So if you're running this like on a web server, you probably don't want to run it synchronously because it could actually take down the server when it's awaiting. I don't know if async has that problem as much as task, but it can do bad things when you're blocking threads this way. But for a console app, this is totally fine. So now if you look at the results again, you'll see it's actually run the async and it'll give you back the image analysis. So run synchronously will actually block until all the results are done.
Okay. So they're running in parallel, but then the run synchronously just means when all those tasks have finished, now we're going to do something.
Yep. I think it's kind of like a task wait all. I'm not sure if that does the same thing where it gives you back I can't remember if it gives you back a task or if it gives you back I think task wait all may give you back a task. In this case, it doesn't give you back like an async. It gives you back like the synchronous result. But similar concept here. It's going to run them in parallel, and when they're all done, it basically is going to block and wait for them to all complete, and then give you back the result.
And so then, at this point, can I just like pipe this into
the type here is an array, so you could do like an array.iter. Iter for iterate.
Yeah.
And then call print results. You don't even have to pass in again. So that we're kind of relying on partial application to solve some of these problems for us. Like print results here on line 34, the long form would be put parentheses around it, put fun, analysis, arrow, print results, analysis, close parenthesis. But since this function basically has the shape of what you want to do, it takes the result you have from each array iteration and then does something and produces a unit. This is, it's totally fine just to put the function. It's similar to, what's the method invocation syntax in C#? Or if you just put the method name, you don't have to wrap it in like a func or a delegate or any of those types of things.
Right.
You have the name is sufficient because the shape of the type is what is expected. That's what's going on here. And actually now results is probably going to be an array of unit or just unit. Okay, yeah.
Yep.
Because iter doesn't do anything in the end. So now you can actually get rid of let results equal and just have the image list and the pipeline.
So now if I run this, we should see the descriptions coming back for both of those.
That's right. And because you're doing this synchronously first, it's going to wait for them to complete, and then it's going to print the results. They may still be in a different order because the order will be based on which one finished in the parallel. So if you run it multiple times, you may see different orders in here, but it won't be all jumbled up as if you as it would be if you were printing results in the middle of each async process. So anyway, I think by doing this, we've kind of tested the design a bit, right? I think we would both say we're probably satisfied with the way this is laid out, and that client's being passed in first, so you can apply it and then just reuse the function or functions if you have more.
And then just to prove the fact that if we added a third or another image to the list, we don't have to change anything else.
Mm-hmm.
Yeah, so
cool.
There we go. I like that.
Excellent. Okay. So I have another question. You used a test client, which is a good idea to do. But what prevented you from running this in like an F# interactive script?
Probably the fact that I spend most of my time as a C# programmer, and as a C# programmer, I am used to creating test clients because the interactive shell for C# is not as robust. So if there's anything that prevented me, it was probably my own biases.
Okay. There's certainly nothing wrong with this. And also I was just curious because a lot of times I use script files. However, there have definitely been cases where weird things happen in them, like dependencies don't load properly, or they break in weird ways that doesn't normally happen in a test client. So I wasn't sure if you had started there and it didn't work, or if it was just a familiarity thing.
Yeah, one thing to remember, and I don't know that we've said this in this recording, but the way this started was we took the sample code from the FognitiveServices documentation that was C# and basically just transported it over. So we kind of started it in C# mindset and have worked it to be F#. So there's still some C# things that probably bleed through.
Yeah. I think you mentioned before we started the call, the first or default up here.
Yeah.
Which is funny because like this is actually probably a nice way of doing it, given that it lets you do just dot into several things. Whereas most of the time I would hit captions and see like this is a sequence or something, or an array, and I'd pipe or do something to pattern match it. Whereas this seems like a pretty reasonable option. Now, one thing I would ask about, looks like first or default. Default's probably going to return a null. Is that right?
So it could. This is one of the things I actually need to do some more research on, just in terms of how the FognitiveServices API works. It seems like there is always a caption, but yes, that's it. The right way to do this would be to check if first or default has a value. Oh, I guess, well, yeah, we'd have to see if it returns null.
Okay. Would you want to do that real fast?
We certainly can. Yeah, so we could do, I don't know, should we break that out into its own string? Or
We could, or we could just pattern match on the captions here. What is captions, by the way? Is it an array or a
captions
seq?
is,
It's an iLists. So
yeah.
that in F sharp, that would, well, I guess it would still be iList. I don't think that's a, I don't think there's a, the list, generic list type is a resize array in F sharp, but I think iList is probably just iList. So this would probably be like a seq.
Yeah, I think so.
Okay.
But I could, let's see, let captions equal this first part.
So you could turn this into a list or an array, or you could even do like first to default like you have there. There's an option of obj, which will take an object and make it an optional value. And then you could pattern match on the option. So we could do any one of those several possibilities if you wanted.
I guess I don't have an educated opinion on which one was best. I'd be curious to see a couple of them.
Yeah, well, let's try try piping to seq.toList, I guess would be a good one to try. Okay, so now if you matched on captions here, so now I'd probably match first in like an empty list. That's just yep, and then arrow, and then print no captions available or something, or no description. I don't know exactly how you would want to print that out. Yeah. And then the second one, it's so, and instead of doing the empty list like you did there, there's two ways you could do this. One is probably better than the other. So pattern matches in F sharp are complete, right? You can't have like empty, or you can't have options that don't work completely. So the cons operator is the colon. Are you familiar with that one? So
roughly.
Yeah, so you are like below here. You did the on line 29. You did a list with semicolons in there in the list to separate the items. You can also do like head colon, and then if you wanted to say this only has one element, you could put the empty list at the end. So that would mean this is the same thing as like open square bracket head close square bracket. We don't want to pattern match only if there's one item at the head. We want to make it like we want to just get the first item off of the rest of the list. So an underscore can be used instead of the empty list to say, I want any list as long as it has a head item. So put leave your head, head colon, and an underscore, and this will match on any list and give you back the head in the variable head. So now you could print, you basically, yeah, exactly.
What is head here?
I think you need to get the indentation fixed. So like your let caption, you probably need an equal. You don't have an equal after that. There you go.
Does it have to be indented all the way out to the match?
Yep.
Okay.
Either equal to or past the match. There you go. So now caption should be a string. And I don't know what head is here, but it has a dot text, and that's
head is caption. The image caption.
So now you can just print fn description %s caption. Cool. And now you won't hit any weird null reference exceptions by doing it this way.
Okay.
Did you want to see what would happen if you do the first or default and match as an option? It's roughly the same thing, just a slightly different approach. But
yeah. How would that look?
Okay. So if you do, go ahead at the end of captions on line 12. So this would require that you open the system.link namespace. Go ahead and leave lines 13 through 15.
Okay.
We'll just change them up. So you already have system.link open because you had first default earlier. So this would be one difference. So here you don't have to have that. Now you do. If you do at the end of captions on line 12, analysis.description.captions.first-to-default. Okay, and then pipe that to option.ofobj. There's also of nullable, which is pretty nice for nullable values. But so now if you look at captions, this isn't really captions anymore. It's just caption, right?
Right.
And you could leave it as caption since you have caption defined below. So now this thing is an option. You can now match. Yeah, there you go. By the way, those I think if you just, yeah, there you go. So now your match caption instead of captions. And now instead of the empty list, it's now going to be a none.
Is that capitalized or?
Yeah, capital N. And then below, it's some head or some text or some whatever you want to call it. You can either do open parentheses and close parentheses around the name you want to give it, or you can just put a space. The parentheses are optional.
So I can just do this?
Oh, you need to give it a name. So like some head or an underscore if you don't care about what the value is, but in this case we do. Okay, so notice the difference in these two. The first one converted, if you had like hundreds of captions, it would make a list out of all those captions first and then match. And then you're doing sort of like if it's empty, then there's nothing. If there is something, give me the first one, but you have to first eagerly read all the values off. I assume the iList, this captions, it's probably loaded them all anyway, so it's probably not a big deal, but you are converting from one type to another. Here, you're just pulling off the first one and converting that into an option. And this pattern match is more exhaustive because now I have none and some head. Not really more exhaustive, it's just that you have one or another possibilities. Whereas the previous one, you had sort of you have a list and you're pulling off the top part of the list, which is really what first to default is doing. So you're basically doing the similar thing, you're just putting it in sort of a different place. But the result is the same thing.
Right.
So that one's probably more of a, pick whichever one makes most sense or that you like better.
Yeah, I guess the main difference in what you'd want to do is here, like you said, we're already forcing ourselves to only the first one, whereas in the previous implementation, we had to narrow down to the first one in the pattern matching. Mm-hmm. So if we had a case where maybe we wanted to return multiple captions or look at multiple captions, then we would need to go back to that previous implementation.
Yep. Yeah, and another thing is a difference between like list and array. If you had in the previous one, if you had done seek.toList instead of toArray instead of toList, the ability to pattern match becomes more difficult. So list is pawn cells, or it's a linked list. You can get the head, you can get several items with a trailer of like, I don't care how many are beyond this point, I just care about this many. Whereas with an array, if you want to pattern match the array and get values out of it, it has to be an exact match of the length. So list is a much better way of doing pattern matching if you want some of an arbitrary length of items.
Is that another way to say that the cons patterns work on lists?
Yep.
And the cons patterns just give you more flexibility?
Yeah, that's a good way of saying it. Yeah. Arrays are typically more efficient. If you're doing lots of processing, arrays tend to be the more performant option. But list is a much easier thing to use for pattern matching purposes.
Okay, I didn't know that. I assumed that in F# we always wanted to prefer the list, but you're saying that when there's performance implications, we should prefer arrays.
It depends on how many operations you're doing and lots of other caveats there, but arrays, just from different dojos and workshops and things I've done, I've tried seeks and lists and arrays tend to be the better performing, but that's not like a silver bullet by any means. There's certainly situations where lists can actually be a pretty efficient data structure. It just depends on what you're doing. If you're changing everything all the time and remapping whole lists at a time, arrays tend to be, especially if you give them a size. I guess it's better to say you can optimize arrays more easily because they're a discrete segment of memory, and you can always size it to the right size all the time if you want to. There's also ways of mutating the array that you can leverage to optimize performance if you need to, but if you're sharing like whole sections of lists can sometimes be more performant.
Okay.
Seeks can be more performant memory-wise sometimes if you're able to kind of read it at a steady kind of window of memory at a time, and you have a very large file size. But again, it's sort of dependent on what you're trying to optimize for. In this case, optimizing for pattern matching, lists are more flexible.
All right.
Of course, we're still in the test client. We haven't even moved into the library stuff yet.
But that's part of it, right? Part of the reason that I wanted this library to exist was just so that people could see how to consume it and how to work with it. So this exists as part of the documentation.
Cool. Yeah, this is good. Okay, and that's like you also have like tags.get and colors.get. That gives you colors back and okay.
Yeah, the captions that were coming back were just a list of string. The tags were a little more involved, and so we had built out some getters to kind of take it from the image analysis data type coming back from the SDK and making it more of an F# data structure. So we were converting the tags, let's see, which I think, this is another iList of image tag, and basically converting it to a sequence.
Okay.
And also, because I remember why we did this now. Sometimes some of the parts of the tag were coming back as null, and we wanted to make it optionals.
Okay.
No, I sorry, I'm thinking through the whole sequence. We made it so that the nulls got filtered out with the sequence.choose. That's what it was.
Okay. Yeah, that's right. So one thing here also I can see, you could actually only match on t.name and move the t confidence down into the creation of the record if you want to.
Okay.
Does that make sense?
Yeah, well, talk me through it.
Yeah, so there's already, as we were looking at when we did the option.of_obj, there's also an option.of_nullable. I'm guessing confidence is a nullable float.
Yes.
So you could actually just do, if tname is null, then none. If tname is not, so like the other option here, then you have sum name equals name, semicolon, confidence equal option.of_nullable t.confidence. And then you just have two cases here. You don't have to do checked has value, because option.of_nullable will convert it correctly into an option type.
All right, so you're saying I'm going to take this part of the match out.
And then you can get rid of the last line entirely. And then get rid of the comma, underscore, and comma true. And then instead of sum t.confidence.value, just replace sum with option.of_nullable. And then remove .value. And that gives you the same thing.
All right, so this is because confidence is a nullable float. It's basically going to convert my nullable float into an option. So confidence is a float option.
Yep.
And if confidence is null, if this confidence is null, that will now be none. Basically, right? Okay.
Yep. So that just cleans that up just a little bit, but
yeah, and also I didn't realize there was that option of nullable, which is valuable.
That's a fairly recent addition. I think that came in F# 4.1 or something. I don't know exactly which version, but it wasn't. It hasn't been around forever, so I haven't actually seen it that much in sample code or examples anywhere.
No, and that's really helpful because, like I said, I spend a lot of time in C# world, so I spend a lot of time kind of at that boundary between the two, and having that of nullable function, I could see coming into play a lot.
Now, here's something interesting. I noticed you're making a list of the sequence of tags, but back in your program, your client program, you were still using seek.iter instead of list.iter. Which isn't necessarily, again, a big deal, because seeks will work with other collection types just fine. But you could use list.iter here if you wanted to. Again, not really materially changing anything. Just is there a reason? I think I remember when we were working on this before, you had seek because you were actually getting back the seek and you were printing it out all straight, correct?
Yeah, probably. Yeah, that's probably true.
Okay.
And I probably have a similar thing here where my colors is probably returning.
Well, it looks like here colors has a colors property, colors field. Oh yeah, it is a list, you're right.
Yeah, but now that that's a list, we could do a list.iter on it.
Yeah, again, it won't matter especially since you're iterating, it's not going to do anything important there. So you could go either way at that point.
Yeah, I think it was just a remnant of the fact that at one point it was operating on a list of JSON objects, or maybe it was operating on the iList. So, and I never updated the output code. We haven't looked very much at the colors code.
No.
Yeah, we manipulated this one a little bit to have a type here where it's, I know it was before there was the type that comes back from the API was like a Boolean. It was a nullable Boolean. And so we converted to either be black and white color or unknown. Yeah, because let's see.
So here's another one where you could leverage the option of nullable if you wanted to, and then option map or something like that, instead of the if and match.
Okay. So instead of saying if color type has, I could do what? Color type, pipe that into option dot of nullable.
Yep.
And then match on.
So that first, your previous if has value becomes the first match here. trying to think if this actually makes it any better. It probably doesn't actually help much. I mean, this is one of the funny things, is just trying to look through stuff, right? Sometimes it may help, sometimes it may not. In this case, I don't like the difference here would be this match on color type dot value becomes another sum or none, and you return different things that way. So yeah, you can get rid of that. Yeah, and then color type dot value becomes CTO. Oh no, never mind. That one would say the same, I think. CTO dot value, right? Because it's a true or false, or is CTO true or false?
It's a Boolean.
Here, yeah, you have. Yeah. And here, I mean, maybe even you just replace this with like a one-liner: if CTO, then black and white, else color. But if it's none, you're going to get your unknown. Like this match CTO is probably a longer way of expressing the same thing you could do with an if-else.
So let's see, I could say if CTO, then
black and white. So basically it's if true, then black and white, else color. Introducing some VB, huh?
What?
You put a capital else.
Oh.
Cool. So again, I don't know if this necessarily clears things up to you. I mean, to me, maybe because I've been looking at this and working in F# so much, this looks more readable to me, but we really didn't change anything. We took advantage of a few operators and slightly modified the code. Maybe that's more helpful, maybe not, but.
See if I can pull them up side by side here.
I mean, it still reads essentially the same, but. In fact, maybe the way you had it before with the has value, if you just did the if, then, else on the top and the if, then, else on the bottom, might be even the better possible way of doing this as opposed to do an option of nullable. I'm not sure.
So you're saying go back to this, but then replace the match with.
Yeah. I mean, you don't have to. It's just more like what's more readable, what's not. I don't know. What do you think? Do you like this better, or you like what you had better?
I don't know. I'm not sure which one I like better. Which
What
I guess
would yourself 3 months from now come back and look at this and think?
I feel like the one on the right, the one that we have created, makes a little more sense as an F# developer, just because I'm not worrying about the has value. Has value to me seems like a very C# or VB concept.
Okay.
But I suppose it's actually a .NET framework concept because it's in the nullable struct.
Yep. It's certainly not something unfamiliar to F# people in general. It's just we typically use options rather than nullables. Mostly for the sake of pattern matching. But again, this one's so small, has value, and then getting the value off of color type is not necessarily a big deal. The one benefit of doing it with the pattern matching and options is that you now have CTO, you're not referencing the original color type value. So if you move the code around a little bit, it's something that's not going to like break on you unexpectedly. It'll be very obvious why it broke, if that makes sense.
Yeah.
And you could even flatten the match statement. You can put the color type pipe option dot of nullable or just option of dot of nullable color type in the match expression directly instead of assigning it to a value. And that would shrink it a little bit, and maybe you can make it a little more readable. Not sure. Again, a lot of this at this point we're just tinkering with aesthetics, which is usually not the best use of time, but
No, but
It can be fun.
in a format like this, I think it's fun and a little bit
Yeah.
educational. Yeah, this, I'm not sure if I like that because it feels like it reads funny to have the pipe in the middle of the match width, but
Yeah.
maybe that's just because I've not done it that way before.
Well, again, you can also put option of nullable in front of color type and get rid of the pipe. But now you've got a function call on a value. And that may still not be, that may still be a little weird looking. A little less so, but like the readability sort of suffers a little bit this way. Match of nullable color type.
You know,
Yeah.
oops. Whoa.
That should, too far.
Yeah, I feel like my something in my undo chain is broken there, but that's okay. I don't know. I kind of like this better, where I want to say I want to match on the color type, and I just happen to be piping it to a option of nullable.
Mm-hmm.
But like you said, probably not the most important decision. All right. Is there anything else in here that you think we could tweak?
Oh, this is good. I mean, in general, all this looks good. I'm just throwing out weird suggestions, hoping that they're of some value.
I like that. I like the changes we've made. I feel like they've improved it for sure.
Cool. This is good practice for me, honestly, because I did a session like this with someone not long ago, and I'd gotten really into computation expressions. And I think I went overboard talking about like what can be done with them as opposed to focusing on like the immediate, like what's helpful. So this is good practice for me to try to keep it focused. I'm not sure that I'm succeeding in that, but
It's helping me out quite a bit.
okay, good. Cool. So how do you feel about the API so far? And what other pieces are you wanting to add? So we have tags and colors on here. The ability to analyze an image asynchronously.
Let me see. Where's the... Yeah, right now, so these are all the different features that I have coming back, which are all of the available features. I haven't done anything with the Faces API or the image type data.
Okay.
So I want to spend some time exploring those a little bit more.
Okay. Oh, one thing that I just thought of. So you have tags and colors as modules, right?
Yeah.
And they both have a get. That's a totally valid design. However, I'm wondering, would it be helpful, or maybe more helpful? What's the type of the result you get back that this is working off of? An image analysis, analyzed image, or something like that.
Yeah, there's a type that's in that NuGet package for the SDK called image analysis.
Okay. So one thing to consider might be, and I'm not exactly sure how to phrase this, but if you have a module called image analysis with like get tags, get colors, then that sort of hangs off the type that you're getting back already. They'll kind of overlap them in terms of IntelliSense. And that might make it a bit more discoverable rather than having to know to go to tags and colors to get those functions. Does that make sense?
Yeah. Yeah, you're kind of rubbing up against one of the other decision points that I was trying to figure out what I wanted to do. And that's that right now, when I call the actual API, which is wrapped by this client.analyze image in stream async, I am requesting everything back. So, I'm passing in this array of features, and basically getting them. It's possible that for performance reasons or cost reasons, I'm not sure which, we might want to only request the tags and only get tags back.
Okay.
I don't know enough about the API yet to know if that's something that I want to do. Because
Okay.
basically right now, the way the client works is that it requests everything from Azure and then just picks out the features that it wants to display.
Okay.
So I think one of the reasons I had tags and colors broken out was I had a thought that maybe later I would only get the tags.
Mm-hmm. Well, and that can still be a valid. So like these could be. This might be worth trying real fast. Can you open up tags again? That's what happens if you change. So you have namespace. On namespace, after vision, do dot image analysis. So this will make image analysis a name part of your namespace, and it has a dot tags on it. Can you go back to, let's see, even in here, can you do like analysis dot in here somewhere? Sorry, lowercase analysis. I'm not sure if it'll append the namespace on there or not. Oh, it's already got a property called tag, so it probably won't override it. So I think if you had a module named image analysis, and then even if this module tags is like a submodule, like a module underneath the other module, you'd end up having to put tags and colors, I think, in the same file. But it should hang that off of the image analysis type. So if you just had image analysis, as long as you had everything opened up properly, you would see like, oh, I've got an image analysis. You type image analysis dot. Oh, sorry, that's what I was missing. Type image analysis dot and see what pops up. Nothing. Okay.
Well,
So I think because it's a namespace, it's not working. But
yeah.
Generally speaking, if this was a module up here, and then you had a module tags underneath it. In fact, I think you could rename namespace to module. Try that.
Like this?
Yep. So this will make a top level module. So now your namespace is FognitiveServices.vision. You've got a module image analysis, which has in it a module tags. So now try typing image analysis dot.
I think we're running into an issue because image analysis is a type.
Well, it is, but this should have added on. I think the main thing right now is that because you're inside of the module tags, you can't get dot tags. So I bet if you get rid of this line here, go over to colors. Let's rename this one. What's the namespace here? It's the same namespace, right?
Yeah.
So image analysis should be available. Try doing image analysis in colors, image analysis dot, and see if you get tags as a. Maybe my memory is faulty, or maybe it doesn't like giving modules underneath it. Interesting. Anyway, typically what you can do is you can define a module and then add functions in it. And if it has the same name as the type, when you like array is a good example. Type array, capital A. Type array dot. So you'll notice there's the lowercase ones, but if you keep scrolling, you'll see the capitalized. And those are, in some cases, like static members or instance functions. Or so there's these are all coming off the array type that's built into system.array. And the ones above are all from the array module. So it kind of like mixes them together. And it determines like, oh, okay, I know what this is now. So the idea would be if you have it created in such a way as you have image analysis, it shares the same name as the type. Then if you're dotting into that type name, you'll see all the functions hanging off of it. it might make it a little bit more discoverable, because that's one of the problems in F# oftentimes is you have to know the name of the module to then get access to the functionality. Whereas if it shares the name of an existing type, it can be a little easier to find. If that makes sense.
Yep.
Okay. Now, why it didn't work here, I'm not positive. It may work actually over in your test client, but
do we need to? It's possible we just need to compile it for it to pick up the IntelliSense.
Possibly. I wouldn't think it would need to inside this library, but it certainly wouldn't hurt. And it looks like our hour is up. We probably need to wrap up pretty soon. Again, this is more, I'm suggesting this really just to provide a way of making this a bit more discoverable to people who may not know that it's there, but certainly not a required thing. So here, this is in your test client. The reason it says it can't find it is because tags is no longer at the top level. It's underneath image analysis. So now try image analysis.tags, and it should be available now. Yeah, there you go.
Yeah.
So now so image analysis should still have whatever else it had, but now it's given you submodules of functionality, or you could, get rid of the tags module and have get tags or something like that off of the analysis.
Oh, you know what? Let's see. We probably don't have image analysis is in.
It's in this computer vision.models namespace.
Yeah.
Is that open in your test client?
It's not. We had basically completely encapsulated that.
Yeah.
But yeah, if I open this.
So it doesn't look like it exposes anything that you could call anyway. So it may not be super helpful. It's more just if people know what it is, what the type is, and then type the type name dot, they would see all your module functionality exposed.
All right.
So something to consider. It's certainly not something you have to do.
Yeah, it might be something I want to play around with a little bit just to see how I like it. But yeah. All right. Like you said, our hour is up, so we probably need to respect everybody's time here and maybe move on.
Cool. Well, I hope this was helpful.
No, it was very helpful.
Okay,
I know I learned a lot.
Awesome. Fantastic. Well, thank you, Eric. Anything you want to say in addition to about this library, like where you're going and any kind of help or contributions you would be willing to accept or like to see?
Yeah, let's see if I can find the repo here. The code that we're looking at is all up on GitHub at pottereric/FognitiveServices. If anyone wants to skim through it and offer suggestions, that's great. I would love to get other people's input. There are a bunch of other cognitive services APIs that I want to get to and get wrappers around. So, it's one of those things that hopefully you'll have a chance to add to quite a bit in the coming weeks and months. There is also a test client right now that uses the text analysis to analyze all the tags for the sessions at the StirTrek conference, if you want another example. And there is a NuGet package published for the FognitiveServices library. So, but it's a super early version, so don't do anything. Don't take a big dependency on it.
Cool. Well, thanks, Eric. Looking forward to see how this grows and trying it out myself. I just pulled down the code a little while ago, so I'll probably try to see what I can do. If you have issues or something, that might be a good way to try to attract help and whatnot. I'd love to try to contribute some things if you're interested in that.
Yeah.
Awesome.
Yeah, I'll get in there and try and get some issues published.
Sounds great. All right. Well, thank you for your time, Eric. Thanks for joining us doing the live coding session, and I hope this is helpful for others as well. I will post a link up shortly on Twitter so people can get access to that. And thank you for joining us.
All right. Thanks, Ryan.
Thank you.